Hi, this is Mrs. Often, and I'm here presenting this video on reflections of geometric figures in the coordinate plane. I've created this using the Desmos graphing software, and I'm assisted today by my pet dog, Lola, who is always excited to share with you her barkingly great knowledge about math. Let's get started. By the end of this slide deck and video, you will be able to reflect a polygon in a horizontal line, a vertical line, the lines y equals x and y equals negative x, and lines of the form y equals x plus k and y equals negative x plus k. An important fact to remember is that the line of reflection is the perpendicular bisector of each segment that connects the vertex of the pre-image or starting figure with the corresponding vertex on the image or ending figure. Let's begin by reflecting in the x-axis. The x-axis is the line with the equation y equals 0. We see our starting figure here is triangle EFG. E is located at negative 2, 2, F is located at negative 6, 4, and G is located at negative 2, 6. Once this has been reflected in the x-axis, we see that the positions have changed, and now E prime on our image is located at negative 2, negative 2. G prime is located at negative 2, negative 6. And F prime is located at negative 6, negative 4. We can see that the x coordinates have remained the same, but the y coordinates have changed. Therefore, our rule for transformations, when we reflect an x, each y coordinate is changed to the opposite value. Therefore, the point xy is transformed to the point x, negative y. If we reflect in the y-axis, that is the line x equals 0, things will change in a slightly different way. Once again, we're starting with triangle EFG, and reflecting across the y-axis, we see that the image here of EF and G, E prime has gone from negative 2, 2 to positive 2, 2. F prime has changed from negative 6, 4 to positive 6, 4, and G has changed to G prime at 2, 6. So here, the x coordinate has changed, but the y coordinate has remained the same. Therefore, our rules for transformation are that when we reflect in y, each x coordinate is changed to the opposite value. So xy changes to negative x, y. We can apply some similar rules for reflecting in horizontal and vertical lines. So if we reflect in the horizontal line y equals k, here's our line, and as you can see, I'm reflecting in the horizontal line y equals negative 1. So for this, I'm 3 units away in each direction, and I'm going to transform according to that. That will leave me with E prime at negative 2, negative 4, rather than at 2, negative 2. So this distance here is doubled, and then that's where I'm going to plot my point. I can algebraically calculate this by doubling the value of the y coordinate of my horizontal line of reflection and then subtracting the original y coordinate. This leads to my rules for transformation being when I reflect in y equals k, only the y coordinate is changed. The x coordinate remains the same. I double the value of the y coordinate on that horizontal line, and I subtract the original y coordinate to obtain the new y coordinates for my transformed figure. We have a similar process when we reflect in the vertical line x equals h. So Here again is my starting triangle. When I reflect in this vertical line, as you can see, the vertical line here is x equals 1. I'm 3 units away in either direction. And so my e value here is going to change from -2, 2 to e prime being at 3, 2. The y coordinate therefore is staying the same, and only the x coordinate is changing. Let's look at those rules for transformation. Our x coordinate is changing. We have doubled the value 1 from my x coordinate of the vertical line, and we've subtracted this -2, the x coordinate of my original point, yielding the new x coordinate of 4. As stated, the y coordinate 2 is remaining the same. Now we can also reflect in the line y equals x, and this is something you'll see a lot with inverse functions. When we reflect in y equals x, the x and y coordinates are exchanged. Therefore, e is going to go from -2, 2 to 2, -2. This is a little bit easier to see with point G. Point G is back here at -2, +6, and it now will be at 6, -2. So just exchanging the x and y coordinates there to reflect in the line y equals x. We can also reflect in the line y equals x, y equals -x. Again, I have my triangle EFG here, and there's a little bit of my line y equals x. If you think about this, I am going to end up over here in quadrant 3 from quadrant 1. And indeed, there it is. My coordinates for e to e prime have changed from 2, 2 to -2, -2. That's for e prime. My f coordinates have changed as well from 6, 4 to -4, -6. And my coordinates for g have similarly changed from 2, 6 to -6, -2. So you may notice a pattern here that I have reversed the order of the coordinates and changed both of them to the opposite. So that is my rule for reflection there. So my original coordinate point x, y, the order is flipped and it is changed to the opposite value. Therefore, x, y becomes -y, -x. Now, there's not quick and easy transformation rules for reflecting in the lines y equals x plus k and y equals -x plus k. However, what we can do is to construct the perpendicular through each vertex to the line of reflection, locate the point of intersection of the perpendicular line and original line. This is the midpoint, and then determine the other point to find the reflected vertex. We can then repeat this for all vertices. Here are some pictures of this happening. This is the line -x plus 3. And here's the line x plus 4, showing figures being reflected across them. We can see that f has been reflected to create f prime, e is reflected to create e prime, and g is reflected to create g prime. Similarly here, we have g prime, e prime, and f prime. You'll notice that in these reflections, lines that were horizontal now become vertical and vice versa. I hope this has been an informative experience for you, and you can explore these figures further with my Desmos activity. Thanks and have a great day.